Okay, looks like we're recording. So this mini lesson is taking a linear equation, a straight line equation, and making a table of values so that you can graph the line. I'm not going to draw the graphs because I want to do 4 examples and I don't have room to put more graphs here. But I do want to show how the y-intercept is useful, whether we know it as soon as we look at the equation or not. Because a straight line equation is not always in y equals ax plus b form. We use algebra, which you've heard of, because in the 2101 book, it's sort of about straight lines and algebra at the same time. We use algebra to get an equation into that y equals ax plus b form, unless we're lucky and they gave it to us already in that form. The thing is, where these are really convenient for building a table of values, you can still build a table of values when you don't have it in that form. So I'm going to illustrate that by doing some examples. So the first one, I don't have space to show all the algebra for these first two, so I'm just going to do it out loud. And then I'll show more algebra when we do the last two, because I'll be able to erase the first two and then I'll make some room. But the thing is, y equals ax plus b form makes it easier to do the algebra in your head. So if I want to know my y-intercept, well, it's 3. And I can write the point 0, 3 into the table of values right away. That's one of the things that's so valuable about having this form. As soon as we look at what we have there, we know the y-intercept. We stick it in the y column and we put an x 0 in the x column. And we have one of our points. Now, what if x is 1? It's fast to do. I'm saying my x is 1, my 1 is being multiplied by a 2, my x is being multiplied by a 2, so 2 times 1 is 2, and 2 plus 3 is 5. I have the 0.15. I can fit any number I want in the x position, and it's really still that easy. If I make x negative 1, 2 times negative 1 is negative 2, and negative 2 plus 3 is positive 1, and I have a third point. So that is fast to do the algebra. I could show the steps of algebra if I had room. But I'm also able to do it more quickly, whether I'm writing it down or not, because this form of the equation is so useful. Second one, we have a negative a. So we don't care. We can do the same thing. We're going to make a table of values, 3 points in it. And our y-intercept is going to be 0, 2. I did the same thing. I just looked here, and since it's in y equals ax plus b form, that plus b is a plus 2, so plus 2 is my y-intercept. And therefore, I just put a 2 there, and I put a 0 in the x column. I have the point. If x is 1, negative times 1 is negative 1. And negative 1 plus 2 is positive 1. I have a second point. If x is negative 1, this negative 1 times that negative 1 is positive 1. And positive 1 plus 2 is 3. You have to watch out for signs, but always in math, you have to watch out. Negative signs have a way of tipping you up if you try to go too fast. But again, I'm able to fill in the table of values very quickly because the y equals ax plus b form is so useful. And I start out with the y-intercept in both of those first two examples because it's just sitting there waiting for me to pull it, like pulling an apple off of a tree. Okay, now I'm going to erase the first two examples, and I'm going to use the space to show the algebra for the third example. Because it's not quite so fast now. I can't just pull a y-intercept out of this like an apple from a tree because it's not in y equals ax plus b form. I'm not interested in using algebra to convert it into y equals ax plus b form, even though I know I could, because I want to show that I can still fill in a table of values even when it's not in that form. And I can still find the y-intercept. This time I start by putting a 0 in the x column. Whatever y I get when I replace that x with 0 and simplify is going to be my y-intercept. So I take my equation and I write it again, except I'm replacing the 0 with the x with the 0. And 2 times 0 is 0, so that cancels very quickly. We end up with negative 3y equals 3. I'm not finished. Algebra forces me to isolate my variable. So since my y is being multiplied by negative 3, I divide both sides by negative 3. These cancel. Y is isolated. 3 divided by negative 3 is negative 1. And I have my y-intercept even though it wasn't in that form. I couldn't see this in the equation. I can still find it. If x is 1, I'm replacing the x with the 1 in the equation, and I just copy the rest of the equation. 2 times 1 is 2. If I move this 2 to the other side, it becomes negative 2, and I have 3 minus 2. 3 minus 2 is 1. I'm nearly there. I'll write it like that. I'm just copying down the left side right now. If I divide both sides by negative 3, then y is equal to negative 1/3. Can I fit that? It's hard to fit it. I'll write it here. Y equals negative 1/3. Oh, that's a bit of a weird one. It's a fraction. I could go into decimal instead if I wanted, though. Negative 1/3 is negative 0.33. I still have a second point. Now, I want to find a third point. What should I do? Do I have enough room over here? I think I'll have enough room over here if I move my chair. I'm going to take this equation and I'm going to plug it in with something, and I'm going to try to avoid getting a fraction. Let's see where I can fit this. Let me think here. How would I replace y with the 0? I think I'm going to get a fraction anyway, but I'm going to do it because it just shows a useful thing you can do. You can make up numbers at random and stick them in the table, but you can also look at the equation and try and think of numbers that will be convenient. If y is 0, well, that's convenient. Just like x was being 0 was convenient because things simplify quickly when you multiply by 0. Well, that's going to happen again here. Now it's y that's equal to 0. So I'm writing, making sure it'll still fit on the chalkboard wall, 2x minus 3 times 0 equals 3. This time the y is taken away and replaced with the 0. And that cancels. So I have 2x equals 3. If I divide both sides by 2, these cancel, and x is equal to 3 over 2, which is 3/2, but I can also write it as 1.5 if I want the decimal. So either 3/2 or 1.5. So there I have a third point. I have the y-intercept and the x-intercept. Convenient. Yeah, x-intercepts exist too, and they're also useful. Okay, that proves that we can do that. I'm going to do it again with the last one. I'm going to have way more room this time because I'm going to erase the third example. And erasing so quickly while students are still looking at the example is usually dangerous, but not when you record the lesson and the student watch it again later on YouTube or wherever else you provide students with videos. So 2y equals negative 3x. I look at this, and right away I know I'm going to get 0, 0. But that's because I've done this so many times. So the student isn't necessarily at that stage yet. I think I'm going to get 0, 0 as one of the points. And that means that both of my intercepts will be 0. I'll have found both intercepts in the same point, which will be the origin. I can tell you how I saw that. There's no +7 or -2. There's no constant term in this equation. When that happens, you have both y and x, but there's no constant term. You end up with the point 0, 0, and we'll see it happen because I'll do the algebra. If x is 0, 2y is equal to negative 3 times 0. And negative 3 times 0 is 0, so 2y equals 0. If I divide both sides by 2 to isolate my y, yeah, it's isolated, but 0 divided by 2 is still 0. I got the point 0, 0. I can fill it in the table. Not so bad. What if x is 1? 2y equals negative 3 times 1. But negative 3 times 1 is negative 3. So I have 2y equals negative 3. That y is messy. I'll make it a little bigger. I divide both sides by 2. The y is isolated. Negative 3 over 2 is going to give me negative 1.5. And I have another point. Where will I fit best the third one? Oh, it'll fit over here. This chair's in my way again. I'll trip over it someday. Okay, what if I make x equal to a negative number like negative 2? 2y, making sure this will fit, yes it will, equals negative 3 times negative 2. Negative 3 times negative 2 is positive 6. And then if I divide both sides by 2, these cancel, y is equal to 3. I have the point negative 2, 3, and I need the chalk. Negative 2, 3. Whoa, I broke the chalk. Quickly find a piece of broken chalk so I can finish writing my 3. There. I have a third point. I found my y-intercept and my x-intercept. I was able to do it without the equation being in the form y equals ax plus b. It's extremely useful, that form, but you don't need it. You can still do a table of values. And if you can make a table of values for an equation, it means you can graph the equation. And that gives you all three of the components, right? Besides the situation, it gives you the equation, the table values, and the graph. Whenever you have one, you can find the others. That's it for this lesson, but I think it's a good one. Let's hope I can find the file after I am meeting.